Good morning.
Good morning.
Good morning. Professor Marwala, colleagues, friends, it is my pleasure to welcome you to this distinguished public lecture organized by the NTU Institute of Science and Technology for Humanity. It's quite a mouthful, so we call it in short NISTH. Before I introduce you to our distinguished speaker, let me say just a couple of things about NISTH, what it does, and why we are doing it. NISTH, I think you will agree with me, is in fact not only important but also overdue. In a country like Singapore, with its aspiration to become a smart nation, a smart city, we have to remind ourselves, for those of you who are not in the humanities, you might be interested to know that the word smart actually is derived from a word meaning getting hurt. You're smarting from something. Every new innovation, every new technological advance will come with its intended and unintended consequences. There is no question that technologies promise to improve our lives, create better societies for humanity at large, but at the same time, I think it is our responsibility also to anticipate, and of course, better still, to mitigate some of the unintended consequences of technological advances. Some of these adverse effects, in fact, may be intentional, and that is quite unfortunate, whether due to abuses of technology or other designs. Against this background, NTU decided to establish NISTH, leveraging the strengths we have in science and innovation, technology and engineering, and trying to bring together colleagues from other fields, including the humanities and social sciences, to come together as a collective to address the real impacts of science and technology in society. And NISTH will focus especially on areas such as responsible innovation, rather than waiting for unwanted consequences to come along and then you try to fix them, create a patch, to use the language of computer science, quick fixes until the next problem arises. We want to put responsibility back into the very process of innovation itself. In an age that has come to be known as the Fourth Industrial Revolution or Industry 4.0, increasingly we have to worry about humanity 4.0. But there are a lot of ethical, regulatory, and governance issues that need to be addressed, and that will also be a major focus of NISTH. And thirdly, being in Asia, being in Singapore, which is a highly urbanized environment, we also want NISTH to look at the new emerging urban Asia. So these are the general areas that NISTH would like to focus on, and we invite all of you to come to our activities, apply for our fellowships and research grants. We are also hoping to engage the global community in furthering the work of NISTH, and we are particularly delighted that the University of Johannesburg has agreed to work with us in not only this, but in other areas as well. To those of you who may not be aware, NTU and the University of Johannesburg have actually established a Johannesburg Institute for Advanced Study in the beautiful city of Joburg. I think eventually we would want to welcome colleagues from WIT and WITS and other universities as well, but we are the two anchor hosts of this wonderful establishment that welcomes visiting fellows, that organizes a lot of research activities that I hope will be of interest to many NTU colleagues. Today, we are delighted to welcome Professor Tshilidzi Marwala, the Vice Chancellor and Principal of the University of Johannesburg, to visit NTU, to visit the College of Arts, of Humanities, Arts and Social Sciences, and to deliver a distinguished public lecture under the NISTH auspices. Professor Marwala, I think it is fair to say, ever since he obtained his PhD in artificial intelligence and engineering from Cambridge, has been a vocal, has been a leading voice in addressing issues relating to artificial intelligence and society. If you go to YouTube, you will see various recordings of Professor Marwala's thoughts and appearances. He has also been a prominent opinion shaper, writing for major publications such as The Economist, Companies, and other leading outlets. And we are very happy that Professor Marwala has agreed to take time from his busy schedule in his very short visit to Singapore to share with us his views on the fourth industrial revolution and society. Professor
Marwala. Good morning. No, thank you very much for the invitation to come to your beautiful campus. This is my first time coming to your campus. I have been to Singapore many, many times, and I'm quite excited to be engaging you on some of the things that have concerned me over the past few years. So what I really want to do is to talk about the fourth industrial revolution and its impact on society. So I will talk about how the fourth industrial revolution is changing economics, not just economics practice, but also theory, how economics is changing, the theory of economics is changing as a result of automated decision making. I will also talk about how it impacts on politics. In particular, I will talk about interstate conflict, how we can be able to use some of the technologies that are emerging out of this to minimize wars. I will also talk about its impact on psychology, medicine, and engineering, and then we'll conclude. Perhaps before I just start, maybe I should just briefly talk about this concept of industrial revolutions. I know there are arguments as to when did the first industrial revolution occurred. You know, some people think the agricultural age, the emergence of the agricultural age, was some version of the industrial revolution. But I'm just going to take a conventional view on industrialization. The first industrial revolution happened in England. It's quite amazing that such a small island, because it's an island, was the first country to industrialize. If we were to take probabilistic views, it should have been China or India, given the population density. But it happened in England, and the reason for that was because of the scientific revolution that preceded it. We know about Newton's laws of motion and his conception of gravitation, and that obviously ended up giving us our understanding of thermodynamics. The steam engines was was what emerged out of that era. The second industrial revolution actually came about, was industrialized in the United States. But the ideas were also again from England. We all know about Faraday. Faraday actually never went to university. So he was playing around with a magnet, and he realizes that if you have something that conducts electricity, and you put it next to a magnet, and you move it, electricity is generated. And the corollary to that is that if you put electricity next to, in a conductor next to a magnet, it moves, which is an electric motor that is used to power our production lines. And obviously it gave us electricity, the assembly line, mass production of goods and services. The third industrial revolution again had to do with semiconductors. These are materials that conduct electricity under certain conditions, and therefore you are able to use them as effective switches. It led to the digital revolution. Of course, if we are to be precise, you would even and it will be correct, that the telegram was probably the first device of the digital age. It was manual. People had to read ones and zeros and translate them into words. But nonetheless, it was definitely digital. And then the fourth industrial revolution is the era that we find ourselves. And what we are seeing now is intelligence is being brought into machines. So we are able to replace human beings. You know, the concept of work is going to change quite dramatically, and we need to start thinking about the future of work and how we organize society is going to be quite critical. You know, if factories are going to be smaller, you know, what is the meaning of life? You know, if factories are going to be smaller, and perhaps tax collection might also reduce, how do we make sure that society has a stake in us as countries? Now, one of the principal drivers of the fourth industrial revolution is what is called artificial intelligence. So I just wanted to explain what this is all about. You know, artificial intelligence is the process of making machines think like human beings. And there are various types of artificial intelligence. You have machine learning, which is really a statistical approach to artificial intelligence. And within machine learning, you have deep learning. Deep learning is not really new technology. It's just scaling up, given the fact that we have bigger computers. Machine learning is not the only type of artificial intelligence. You also have computational intelligence. And I think one example of computational intelligence is the intelligence that you can observe in a colony of ants. It's actually quite impressive intelligence. Where I come from in South Africa, you have lots of ant hills. In fact, the first person to come up with the conception of intelligence in ants was a famous South African writer called Eugene Marais. You know, of course, Eugene Marais published his theory on a local magazine, and a Dutch Nobel Prize winner obviously took the ideas. He was caught. But quite exciting. So this is where we use nature to build machines that are intelligent. Then we have soft computing, which is more fuzzy logic, where you are trying to codify, wisdom that you see in human beings. We just recently published a book on just summarizing the whole things and conceptualizing it in an easy-to-read fashion so that people can be able to understand. And one thing that we try to do, because what I have often seen is that the experts in this field tend to hide behind sophisticated mathematics. And because of that, we forget to actually understand what is really, really happening here. So we want to simplify things so that people can understand the principles and not hide behind big mathematics. Now, big data is basically the application of artificial intelligence to analyze huge amounts of information. Now, these are some of the technologies that are driving this. I've already talked about artificial intelligence. 3D printing is another one. Blockchain is another interesting area that we have been quite interested in. Smart infrastructure, biomedical engineering, and biotechnology. Now, I'm going to just start by its impact on economics. So, for example, demand and supply. If you go to a conventional shop now, they will give you a price for the good. And that price is derived from what we call aggregate demand and aggregate supply. So you are subjected to the loss of averages. Of course, now as we move trading into online platforms, then you are able to do individualized demand and supply. We actually did an experiment, to go and buy the same book from Amazon. And we realized that we got two different prices, depending on who was buying. Because they can be able to understand your individual demand and supply. So the other theory that is being changed is the theory of quite a controversial theory, rational expectations and rational choice. Because human beings are not rational. They don't calculate before they don't do sophisticated calculations before they take their decisions. It's also changing quite drastically. Bounded rationality, Herbert Simon came up with the theory of bounded rationality and behavioral economics. Once you automate any process or any transaction, what you are basically doing is to reduce the impact of human behavior in that transaction. Game theory and mechanism design is also changing. Quite an important area is the issue of causality, which is quite key, especially in medical sciences. When you do clinical trials, what you're really doing in clinical trials, you want to observe whether a particular piece of medication is able to heal a particular disease. And for you to be able to do that, you are supposed to estimate whether if you had not subjected that patient to that medication, the outcome would have been different. And we call that counterfactuals. So counterfactual is a very central definition of causality. And when you do a control experiment, what you are trying to do is to estimate the impact of giving somebody a medication and observing the impact at the same time, not giving that same person the medication and observing the outcome, which is physically impossible. That is why the control experiment must be as identical to the real experiment as possible. Pricing and portfolio theory is also changing. So this is the work that we did not too long ago as to what happens when we automate decision-making in the marketplace, to a theory that Stiglitz and Akerlof won Nobel Prizes for, the theory of information asymmetry. And they use the used car salesman, that you have two used car salesmen. One sells good cars, another one sells bad cars. The customer does not know. So what do you think is going to happen? And they observe that the good car salesman is going to get out of the market because he's less likely to give discount than a bad car salesman. And therefore, they made a profound conclusion that information asymmetry impairs the market. It destroys the market. Now, when we move to artificial intelligence, in automated decision making, what happens to the theory of information asymmetry? What we found was that it actually reduces the level of information asymmetry in the market. And secondly, we also realized that we also observed that it reduces the volume of trade. Why? Why does it reduce the volume of trade. We found out that information asymmetry also is a very important principle as a basis of exchange of goods and services. So if you have a phone and I have $100 and we need to exchange, you will take my $100 if you think the $100 is more valuable to you than the phone. I will take the phone and give you $100 if I think the phone is more valuable to me than the $100. So that is information asymmetry of perception of value. And therefore, once you kill information asymmetry, then you also reduce the amount of trade. Market efficiency, controversial subject. Markets are efficient. It turns out that the more you automate decision making, the more efficient the market becomes. So in other words, the whole concept of theory of market efficiency is almost dependent on how much technology you deploy. The more intelligent technology you deploy, the more efficient they become. Quite an interesting conclusion. The other work that we have spent quite a great deal of time doing is the issue of making decisions with incomplete information. The reason why we got into this was we were analyzing HIV database in South Africa. So when pregnant women go to government hospitals, they will take almost all the demographic characteristics. How much do they earn? How old is the father of the kid? Where do they stay? And they will take an HIV test. So we wanted to build a model that will be able to make predictions based on that. What we found out was that, no, this database is never complete. You have missing information. How do you still make decisions with incomplete information? That was really the key. And by the way, incomplete information is a good problem to have. The most difficult problem is wrong information. How do you detect that the information that you have is not correct? Whereas incomplete, it is, the information is not there, and you can be able to do something with that. Whether you use the average or whether you estimate. So this is the algorithm that we developed on how do we make decisions with incomplete information. And this is the type of a neural network called auto-associative network. Auto-associative is you perceive the world, you sense the world, and try to reproduce it. So you give it information, and then it tries to reproduce that information. Now, if you have some mechanism that is supposed to transform information that it perceives, and now you give it information that is incomplete. If you put wrong estimation, it fails to reproduce itself. So you can be able to develop an algorithm to identify the missing information so that it is able to reproduce itself. We have actually written a book on this, on how do you make decisions with incomplete information. This is the work that we did on bounded rationality. So what happens, this theory of bounded rationality was proposed by Herbert Simon. He won a Nobel Prize in economics in 1978. So what he was saying was that when you make any decision, you never have all the information at your disposal. Even if you have all the information at your disposal, certainly if you are a human being, you will not be able to use all the information. So if I give you a simple algorithm, if it is cloudy, take an umbrella when you go out because probably it is going to rain. It's quite a simple instruction to obey. But if I give you 1,000 variables and say, this is what you should do given these 1,000 variables, you will never know how to handle it. That is when you start needing a machine. But what happens is that because you cannot be able to use all the information, and the information might not even be complete, the decisions that you make are bounded. That's what bounded rationality is all about. In mathematical terms, we say that the rational feasible space for your decision making is limited. So now what happens when you take such decisions and you give them to a machine? A machine now can be able to look at 1,000 variables and be able to make sense of that. What it basically means is that those bounds that limit your rationality are being moved. So bounded rationality, those bounds in the bounded rationality theory are flexible. The other criteria for rational decision making is the time to complete a decision. So if you could make a decision in 2 minutes and you choose to do it in 1 hour, you are not being rational. It's not rational to do a 2 minutes decision in 1 hour. You're wasting resources. It's irrational. So if you take the decision, such decision, and you take it to a computer, we know due to a law called Moore's law that computers are becoming faster. It means a decision that takes you maybe 2 minutes for the computer to make today, in 10 years' time, it is probably going to take a fraction of a second, isn't it? Which means that these bounds of rationality are also shifting depending on the advances of technology. So they are flexible, So that is another impact. So we actually wrote a series of books on how artificial intelligence is changing the practice of economic modeling. We did some work. I did some work with Evan Hurwitz on how it is changing the theory of economics. So we looked at 15 major economic theories that have been developed over the last 100 years. The second area which interested us quite a great deal is the issue of predictions of conflict, militarized conflict. And people will say, but can you ever be able to predict whether two countries are going to go to war? I think we can. Do you think Swaziland will go to war with Switzerland? Probably not, isn't it? Why? The distances are too far. They don't share a border, and so on and so forth. So we were actually looking at 7 variables and using those 7 variables to model whether two countries are going to go to war. So those variables included, do they share a border or not? If they share a border, we give it a 1. If they don't share a border, we give it a 0. We looked at the distances between their capitals. We looked at the difference in the degrees of militarization. We measure it by how much they spend on military power, and so on and so forth. And we found out that indeed you are able to predict conflict. We tested it on data that have been gathered over the last 70 years, and it is able to do that. So this was quite an exciting work. So you can be able to use technology to reduce the occurrence of war. What did I do? Somebody will have to. You see, when a human being makes decisions, they make a mistake. If it was all automated, it was going to be fine. Yeah. So out of this, me and Monica Lagazio wrote a book, Militarized Conflict Modeling Using Computational Intelligence. This is the Chinese translation of it. They also translated my name, Marwala. Ma is a horse, isn't it? And Wa is a gutter of a roof gutter. And La is to pull, I don't know what philosophically it means, pulling a horse out of the gutter of the roof. Now, we also spend quite a great deal of time understanding. Now, when you have, can you be able to to make computers learn how to bluff. And we did find out that, yes, you can be able to build autonomous softwares that are able to bluff. They actually, on their own, learn how to bluff. And I am not bluffing. And this was on the cover of the New Scientist. And what we also observed was that you are able to study and reach a conclusion that bluffing is actually a perfectly rational action that is intended to maximize utility. Nothing more than that. You do that with the aim of maximizing utility. You might even take a suboptimal decision in order to deceive your opponent. But ultimately, the global decision has to be to maximize utility. Now I'm going to move on to a very important issue that we have been worried about, the automation of our workforce. The use of robots are changing the psychology of people. And one of the areas that we think is important is how does the psychology of people change as a result of automation? I'm not going to talk much about this, but we did write a book on this with Bosching on how the interaction of humans and robots are changing the psychology of people. Now, moving on to medical applications. So this is the application that we did on detection of epilepsy. So normally a doctor will look at this picture and will be able to tell you whether the person is experiencing epilepsy or not. So we took 100 of these, 100 different from different patients, and we gave them to 100 radiologists. And we said, please, tell us what is happening to each one of them. Of course, it's 100 by 100, and then they write it down, and then we store the information. A month later, we went to the same doctors with the same 100 pictures, and we asked them to make a diagnosis again. We were shocked to find out that half of the time they were changing their minds. Actually, quite. When they change their minds, it means it was a misdiagnosis. So now we said, maybe how about if we use a computer? So all we do, we just take a segment, we extract features, put it on some neural network, and it is able to tell you whether this thing is from an epileptic activity or not. Firstly, we found out that the computers are consistent. It doesn't matter whether you come after 1 year. If you give them the same image, they are actually making the same diagnosis. Of course, consistency is not the issue here. The issue should be accuracy, isn't it? And the accuracy, we believe, was over 80%. Quite important. So this is another medical application device that we did. Is when somebody loses their voice. Voice is actually quite a powerful thing. So normally they lose because of the removal of their voice boxes because of cancer. But they can still move their tongue. So what we do, we have this device. You put it into the mouth. Depending on the words that you are saying, it becomes a signal, and you use the signal to reproduce the speech. It works very well. Doesn't work quite as well in our local indigenous languages. Wongani, especially Xhosa, the clicking languages you have difficulty doing this, but nonetheless it is able to work quite well. And it also does not work well for words that you are blowing the air, like "oh," where it's not touching, because the trick here is that it has to touch, the signature is by the touching of the palate. So O and U, you don't touch the palate, but they are different sounds and so on and so forth. But it worked quite well. So we actually have a US patent on this. It's almost like a robot voice. This was on MIT Technology Review. I'll just move a little bit faster. And this is, of course, this is for pulmonary embolism. And again, we are using automated processes to be able to do this. We found out that this works very well, especially in rural areas where you don't have medical specialists. Instead, you don't have a doctor that can be able to make diagnosis. So you built an app like this where, somebody who is not necessarily a big expert can still be able to make a diagnosis and help the patient. We have spent quite a great deal of time working on face recognition. We are launching a big project on that, and voice recognition. The reason why we decided to start working on this was because we realized that these devices that Google is making either does not know how to pronounce our indigenous names, or the face recognition system does not work too well. The iPhone 10 is a classic example. It doesn't work. The face recognition on iPhone 10 does not work too well on African faces. And the reason for that is because the database that was used to develop the algorithm was mainly gathered in Europe and North America. So those devices are coming with an algorithm that was developed using European faces, and then we are supposed to use them. Of course, the solution to this problem is for us to create our own databases. This is the project that we are working on. The second one is on voice recognition. We found out that especially the clicking language, we have a language in South Africa called Xhosa. I don't speak it too well. Maybe Wongani, you can pronounce it a little bit better. Well, how do you pronounce your surname? Yeah. So it and what we find out, if he is saying this, and you just look at the signal, that click is noise. It's like it just goes up. It just goes up. And what we found, and the language itself, Xhosa, is not a clicking language. It's a mixture of two different languages, a Bantu language, which is not a clicking language, and the indigenous language of South Africa, because most of the people you see in South Africa moved from the north. So the indigenous people were called Khoikhoi, they call them Bushmen in English, but it's not a very nice word. So they speak a clicking language. So when the Ngunis came, they interacted with them and they borrowed some words. So Xhosa only clicks 5% of the time. 95% is not clicking. So when you look at the signal, it's normal. Then it will just have a click, and then normal again, click. And most of the algorithms actually eliminate the click. And again, we're working on algorithms to be able to, how do you handle out of the ordinary sounds that do not occur often enough in a language, which happens when two different languages start clicking, start mixing with one another. This is a picture of a bridge in Johannesburg that collapsed. It was a temporary bridge that collapsed. And we have been spending quite a great deal of time is, can we be able to put signals that will be able to detect whether this bridge is about to collapse or not? My grandmother never went to school. She couldn't speak, she couldn't write, and she couldn't read. but she was effectively my first engineering teacher. So she used to make clay pots. She used to make clay pots, so she would go and collect clay, come back, form it, put it in the sun, and then bake it. After baking it, she will knock each pot. Depending on the sound, she will be able to tell you whether this is a good pot or not. And she used to say, if it rings for a long time, it's a good pot. If it rings for a short time, it's a bad pot. The shorter it rings, the shorter it is going to live. So if it rings for like 2 seconds, maybe you can use it for a few days and it's going to break. If it rings for 10 minutes, maybe you can use it for 5 years and it will be fine. That was sort of the algorithm. But the problem was that when she was growing old, I realized that she was throwing very good pots because her hearing was deteriorating. Now, how do you take such technology into the fourth industrial age? And again, it's the same process. That ringing of the pot, we call it vibration analysis in engineering. And that brain that she used to use is what we can call artificial intelligence. You take that vibration data, take it into a computer, and it is able to make a prediction as to whether that particular structure where the sound comes from is good or not. So that is really where we spent quite a great deal of working on this, and this is a book that we wrote on this. And I think what is important here is that sometimes, knowledge does not come from places where we expect them to come from. For a long time, I never thought I will get this complicated algorithm on how to monitor the condition of systems from my illiterate grandmother. And this is, some of the things that certainly artificial intelligence is doing. This is the design of a car, and what happens is that normally what a computer gives you is not necessarily what reality gives you. So we spend a lot of time trying to correlate these models so that they better reflect what reality is. And by the way, philosophically, it's a big subject. How do you know that the model is the correct model? I mean, about 600 years ago, I think it was a British monk, Occam's razor. They basically say that the correct model is the simplest model that describes all your observations. So we spent quite a great deal of time working on this, and these are the 2 books that we wrote on this. And then finally, the issue of monitoring and predicting depth levels using cameras. We have water problem in Southern Africa. You just put cameras all over, and you are able to predict the water levels. This is a patent that we hold. Blockchain is a new issue now. The big issue about blockchain is that it consumes so much energy. And what is going to happen going forward is how do we develop technology that minimizes the energy and therefore the carbon footprint of this blockchain technology. Now, looking forward, I think as the University of Johannesburg, we are leading the drive towards the fourth industrial revolution, the understanding of it, whether it is its impact on society or politics or peoples. We are gathering databases of African faces for effective face recognition technology. We are gathering, developing libraries of African languages so that we can be able to digitally analyze them. We are working on the understanding of the relationship between automation and taxation. Bill Gates was quoted not too long ago saying that we should start taxing the robots. How do you tax a robot? Because something as simple as your word processing software has some robotic features. Automated grammar correction and automated spelling correction is some form of a robot. So how do you do that? But nonetheless, it's an important area that we need to think about. We obviously are expanding quite aggressively our collaboration footprint. We have had very good relationship with our traditional allies in Europe and in North America, but we think that some of the most exciting knowledges are coming from Asia, they're coming from Latin America, so we are aggressively expanding our footprint there. We have, JIAS has been running a series of weekly conversations on automation and the future of work. You bring in the technologists in 1 week, the next week you bring in the people from the trade unions, you bring in the politicians so that we can collectively tackle this problem that is going to come as a result of the advances in the fourth industrial revolution. Thank you very much.
Thank you very much, Professor Marwala, for a wide-ranging, comprehensive look at the various applications of AI and other Industry 4.0 technologies to really all aspects of life and human behavior. We have about 20 minutes for questions, discussion, so I invite the audience to raise whatever questions you may have. And perhaps I can use my position as a moderator to ask the first question.
Yeah.
Do you believe in the point of singularity? And if so, what is your estimation? When will it arrive? I'm learning from my engineering colleagues that there have been various estimates of this momentous, I suppose, convergence, if you like.
Okay. No, I think what I have seen happening is that we tend to measure intelligence in one dimension. So you have a piece of software that is able to do a particular task very, very well. Yeah. And we think that is enough. I think one of the aspect of intelligence that we take it for granted for human beings is the ability to do multiple things well. We can speak very well. We can recognize people very well. I went to my village after many, many years. And people can be able to tell who I am without even me looking at them. While I'm walking to the other direction, 5 years later, somebody is able to tell you by the way you work. A machine will not be able to do that. It will probably only be able to do it if you give it a picture that looks like you at this stage. If I gave it a picture of you 20 years ago, it will not be able to do that. Whereas human beings can be able to do that. So I think it will happen, but until we advance in what I call general intelligence, which is a machine that will be able to do all these things. It will be able to speak, it will be able to write, it will be able to hear, it will be able to, you give it instruction and it will be able to adapt. Then that will happen. But at the moment, people are designing artificial intelligence to do specific tasks. Yeah.
I'll take over from the student social sciences. I'm a professor there. Thank you very much for your presentation. It's really sort of provoking. I have one quick question regarding to the singularity too. So you mentioned that general intelligence is actually kind of a point where it might be able to reach the singularity. But then before that, there's a certain particular kind of issue that AI can deal with. And I'm kind of wondering to what extent So you mentioned about the bounded rationality and also the AI, the relationship between them. And then if we create the good AI, then our kind of boundary is going to expand. And but then the question is to what extent can human beings believe that? Because so if the outcome that coming from the AI is incomprehensible for human being, then like people might actually doubt about it, or like they just kind of follow. But if they follow without kind of thinking about the, whether it is correct or not, then there's gonna be just kind of human being following the outcome of the AI. So to what extent can, I mean, it's kind of relating to the AI and psychology. But then, do you have any kind of idea or view about this kind of dilemma between the AI and the human machine?
Oh, okay. No, thanks. I mean, you remind me of in economics they have something called pricing of derivatives and options. I don't think those models of options and derivatives are actually correct. I think they have become correct because everybody is using them. So because everybody is using them, then they become correct. And there is, there is an element of if we all make decisions based on some form of a code, then it becomes reality. Now, coming to your question, for me, I have realized that when AI predicts, it is doing nothing but rearranging the facts that already exist. I mean, it is a bit controversial, but that is true. In mathematics terms, we say y is equals to fx. That's basically what AI does. X is your observation, y is your prediction. But x already exists, and the function that you are using already exists. So what you are doing is actually nothing but rearranging the facts that already exist. Now, where is the catch? The catch is that when you have things that are out of the ordinary, most of these algorithms actually fail. I think there was a book called, what is it, the Black Swan or something like that. When a black swan comes out of the ordinary, it will not be able to predict because it has not seen something like that. But fortunately, life repeats itself in various forms. I think somebody said first as a tragedy, second as a farce. But life repeats itself as a result. We are able to make predictions. But anything that is out of the ordinary from the information that already exists is actually quite difficult for us to be able to make such predictions. Thanks.
Thank you, Professor Marwala, for a really nice overview of the contemporary applications of AI and machine learning. In a sense, you gave the history of the instrumental capabilities of technologies, and of course, alongside these four revolutions as you've sketched, there have also been developments in critical theory and critical philosophy that went alongside these developments. So in a sense, this sort of started with the European Industrial Revolution, entailing the European Enlightenment. And of course, we know that Enlightenment philosophy didn't exactly yield all of the perfect solutions we wanted. We had, the Holocaust and Soviet totalitarianism. And so these developments run coextensive with technological developments. And so now we've arrived at this potentially fourth revolution. The question, I suppose, remains, and it's more of an open question, what sort of critical theory can we expect in the coming decades? Like, how are we meant to give ourselves some historical perspective on where we are? And the other side of the coin is not what can we do, but what ought we do? And broadening that even more, I guess, I'm a recent arrival from the US, but now here in Southeast Asia, things look a little different. So in the post-colonial context of South Africa, I imagine you have a particular perspective on criticism of science and technology. So I guess I'm just sort of encouraging you to open up the conversation a little bit more towards what a critical theory would look like in this fourth industrial age.
This is obviously quite a difficult question. I'm going to ask Peter, who is who has written quite a bit about critical theory. But before I ask Peter, I would say that whether technology is going to bring positive things or negative things is actually up to human beings to make. Because history is actually made by human beings. You know? So if we are talking about the post-world era, where the jobs are going to be smaller, there will be certain actions that we'll need to take. I was reading a South African, Elon Musk, who originally also comes from South Africa. He was saying that maybe we should start thinking about universal income, you know, because if the work disappears, how are people going to take care of themselves, you know? I mean, I talked about the issue of taxing robots, you know. These are probably some of the ideas of trying to construct a society of the future, given all these developments. And I mean, the big issue is, can this thing, the advances of artificial intelligence, be used in the military settings to make the world much more dangerous than it is now? You know? And the answer is, every technological advances actually has been employed, you know, in the military. But certain choices we'll have to make to safeguard our society. Peter, would you like to add?
Yeah, of course, thank you. This is the proverbial elephant in the room. I don't think that, firstly let me say it's very important that we don't let this debate to be captured by technological determinists. That is extremely important, and I'm glad you raised the issue, because I think this debate is largely driven by technological determinists. And they remind me a lot of the Fukuyama option, this kind of idealism that we'll get to this point and this will be the end of history. I think that the humanities, the project of the humanities, understanding humanity and its link to emancipation, which is the critical theory project, has to remain central to what we do in the humanities. I think we have to resist incorporation without criticism into this project of technological determinism. I think it's evincing itself in different ways in different places. Let me take South Africa as a case in point. There was a huge conversation going on in South Africa about decolonization of knowledge. And where decolonization of knowledge fits into this debate has not yet been sufficiently theorized. So I think that what we have to do as we proceed along, and I'm not going to answer your question, I think it's what you've raised is a provocation, and I think it's really important that we respond to this, to the provocative nature of technological determinism. What is happening in South Africa is that we need to theorize how the decolonization debate fits in to the Fourth Industrial Revolution. And I think at the Institute for Advanced Study in Johannesburg, we are thinking about ways of bringing these conversations together, and it does start with this question of work, because we don't know what the answers are. Let me give you a little example. We brought trade unions in to have a conversation about this, and to be frank, it seems to me the trade unions have theorized about it much more successfully than people in government have theorized about it. So there is a long walk here that we have to do, but this remains for me the central question of these kind of debates about the Fourth Industrial Revolution. And we can't just pretend this is not going to happen. So I haven't answered your question, but I've tried to suggest some comparative things and tried to say it remains front and center.
And maybe just if I could just add to that, I think the role of social science is to also problematize what is accepted as the norm. So, for example, we have to ask, sometimes I'm referred to as being alarmist, we have to entertain the question about where this revolution is taking us as humanity. Because with deep learning, with machine learning, with big data being computed, it is a fact that machines are not only making accurate decisions, but they also at some point are going to see us as being defective, slow, sick. We will be a sick program, which needs to be deleted. Because that is how they respond to programs that are deficient. So it's an alarmist argument, but the point is that as social scientists, we have to entertain that side of things and not only be impressed with, for example, the computational abilities of machines and so on.
Can I just say one other thing? It's really important that we also explore how these conversations are taking place in different languages. Because English is one kind of echo chamber in which this language is taking place. I think we need to think about how it's taking place in different languages. So I think it's very
And I think it's not only different languages, but actually different cultural context, different contexts and different situations, which is one of the questions that I wanted to ask then is not only the role of critical theory in this or how decolonization fits into this argument. I'm interested, sorry Patrick, I'm a sociologist. I'm quite interested in the micro and the situational dimensions of this. So you had a brief slide about the human non-human interaction part. Most of your presentation would be what I would call rather macro-oriented, right? We're talking about trends, we're talking about big problems at the societal level. But I think another way to think about this, and I'm interested in your opinion or your past work on this, is where does the actual, the phenomenological and the interactional aspects of this with human beings actually working with intelligence, whether it's artificial intelligence, machine learning, whether it's smartphones or screens in general. So what place do you see there needs to be a focus on the study of human beings actually interacting with these at that small level?
Look, I think, I did briefly talk about this. One of the issues that we are grappling with is technology bias. The fact that you have a machine at the airport where you put your passport and it looks at your picture and says, you are okay. And then Peter comes in and he says, Peter, you are okay. And Wongani comes in, he says, Wongani, we need to, I cannot see you. And if it was a human being who does that, Oscar, you probably will be starting a revolution, isn't it? But if it is a machine, what do we do? There are obviously regulatory aspects of that we need to think about it. The legal system that we need to put into place. There are issues of what can you import and what can't you import if it is not in accordance to our values. There are also issues of technological development to say, look, go and build a database. Go and build an algorithm that will be able to make sense out of this and eliminate that bias. So I think those are micro issues that we need to worry about. One example is the Google Maps. In South Africa, it cannot pronounce any of our indigenous names. It's almost functionally not usable because they will call Miriam Makeba, Makiba. And if you are a native speaker, you will wonder, who is this? Which street is this one? And of course, we understand why. It's the political economy of technology. That you make goods for the market you want to sell the goods to. So if Google did not think South Africa was the market, they don't make technology for South Africa. They make technology for their markets, but still import that technology to South Africa, whether it fits that market or not. Is inconsequential, you know. And I think on our part, we need to be activist and try to correct that.
NTU has recently established a joint research institute with SenseTime, which is the largest facial recognition AI startup in China, in fact, the largest startup in the world. So we'll make sure to put that to them. Include that in their research agenda. Yes, do you have a question?
Thank you, Prof, for your presentation. I'm curious, given the leaps and bounds in technological advancements in this sphere of the world, and how do you see the advancement of people, of humans? We talk a lot about humanity 4.0. So I'm curious, as you're deep into AI and artificial intelligence, how do you see human intelligence evolving? And what would be a parallel of AI and human intelligence?
Look, I mean, human intelligence evolves rather slowly. You know, the laws of evolutions are rather slow. I think, I mean, somebody was telling me that they have found that in North America, you know, young people are rude because they have been interacting with machines where they are giving instructions, you know. Give me this, give me that, you know. and obviously, when you do that to another human being, that's what you call rude, you know. So it's basically almost a cultural dimension that is changing because you have these people who are interacting more with machines than human beings. I read a study about people in Japan. They say you have people in Japan who are spending weeks without talking to another human being. Because you have all these vending machines. If they want to eat, they just go there, put money, and so on and so forth. And once you put that person to start interacting with people, they are changed people, you know. Because for millions of years, okay, maybe not millions of years, maybe hundreds or thousands of years, human beings were social organisms. So we were interacting and we were speaking and so on and so forth. And technological changes are isolating us. They are making us much more isolated from other human beings, you know. And as a result, our behaviors are changing, and we need to understand that. And we need to see how we interact with such human beings to assist them to be able to, not to lose the dimension of being human, which is, to me, quite a special dimension. You know?
On balance, Professor Marwala, do you think the fourth industrial revolution would exacerbate inequality, or would it help to level inequality? Would it help the rich become even richer, the poor become poorer, or level the playing?
If it is left to evolve on its own, it will widen income inequality.
Yes.
Because it will mean that you know, all you need is just a large balance sheet to be able to go and buy these robots that are going to do a production, and all the resources will come to you and you alone. You know, so the sharing that used to happen through, you know, employment of people, because they are participating in the value chain, is actually going to disappear. You know, but if we intervene, I don't know what that nature of that intervention is going to be. Will it be through taxation? Will it be through any other? We will just have to imagine that, you know. Then we can be able to arrest the situation, you know. When production becomes mechanized and human beings are removed from production, then it means you are leaving a lot of people out of the
Thank you very much, Prof. Marwala, for your talk. I'm from the psychology division. I'm a lecturer here in a teacher course in quantitative reasoning. And we're actually talking this week about how your sort of gut feeling that you have when you deal with complicated or complex or big numbers can sometimes impair your getting to the correct answer. So as we improve AI sort of related technologies and the technology gets better and better, and we have more tools to get us to whatever correct answer, more rational decision that we're looking for, what happens as the divide widens a bit between the quality of the tools that we have and the fact that we're still irrational actors as human beings?
Look, I mean, I think Kahneman won a Nobel Prize for that, and obviously there is an evolutionary explanation why. If I give you 13 numbers to analyze before you make a decision, you simply won't do it. You are not going to pick up a calculator. An average person is not going to pick up a calculator and calculate everything. So that's how gut feeling actually evolved, because we had to make quick decisions without necessarily looking at the details. Now, once you now start having machines make decisions, it means what the behavioral economist Kahneman proposed become less important, because it means the volume of decisions that were being made by human beings who were irrational will start reducing, So I think the consequences of that is that behavior is going to be eliminated from decision making. And by the way, in many instances, it is a good idea. For a diagnosis of epilepsy, behavior is a problem. Behavior of people, of doctors who are not making correct decisions because they slept for 2 hours instead of 5 hours the previous day. The consequences are quite huge. So when you mechanize that, it's good. So rational decisions are obviously good. So obviously, it will change the individual, and then it will change society. The marketplace is a good example to think about that. The fact that now you have automated softwares that are making decisions is actually making the market more efficient. So I think that is a good sign. Maybe the question is, what is our role as human beings then? If we are going to outsource all our decision making to machines.
Well, I think even as a psychologist, I'm interested in also the more micro level, the day-to-day interactions, in addition to, of course, the applications that we talked about today that have been traditionally more mechanized. We still talk to each other and see each other and say hi to each other and have these very small and more human, but certainly meaningful sort of interactions. So I wonder, and I think it's probably something that we all need to do a lot of work to find out, but I wonder how all of this will play into our day-to-day interactions with other human beings.
Yeah. And also on the meaning of life. As human beings, if we have no role to play, what happens to us? Other things, depressions probably will be the consequences of that. But we just need to understand that and deal with those issues.
And I suppose very soon we have to deal with the real possibility of human augmentation. Already the technology is there. So it's no longer just a question of human beings relating to robots. We could be part robotic.
Yeah.
So that certainly...
Maybe not part robotic. More like we have devices that assist us make certain decisions. You will still have human features that cannot be robotized, like falling in love. You can't really robotize that. And you can't. The satisfaction you get when you go and visit your parents, it's things that we can never be able to outsource to a machine. We do it ourselves. We have to do it ourselves. Even though we do buy robots to take care of our parents because we don't want to do it on our own, but that is a different issue.
Yes, please.
Actually, what I have a question here is more on the responsibility. So you mentioned about the robot making decision, but to my understanding nowadays is the robot will make an assumption, and a human being will actually make the decision whether is it true or false based on the assumption kind of sense. Yeah, but you mentioned that in the future there might be general AI or the expert system might be so accurate that most humans will just believe the assumption is true. So may I know who will be the one responsible if the assumption is not true in a sense? For example, is it the engineers or is it the person who believe the assumption that is true, or is it someone else? Yeah, the robot definitely cannot be responsible for their own decision.
So how do you buy insurance?
Yeah.
No, I mean, look, I mean, this is a great question. Who bought self-driving car? Killed someone. And they're finding out that it actually saw the person, but took a decision to kill someone. I think there's a classic example about a car with 4 people driving next to a cliff, and then there is a pedestrian on the left-hand side. On the right-hand side is a cliff. It is traveling at 100 kilometers per hour. And it sees both, the cliff and the person there. Either it knocks that person and saves 4 people, or it avoids the person and fall over and kill 4 people. What should it do? Obviously it depends. If you take a utilitarian view, the greatest amount of happiness to the greatest number of people, then it probably will have to kill the person and save 4 people, because the 4 people you will have 4 people, very happy people, instead of 1 person dead. But how about if the 4 people are all over 90 years old, the person is 3 years old? So those are the decisions that we have no choice but to code them into this. Now, responsibilities is another issue, because we are never responsible in a normal society. We are never responsible for things that we create. For example, if you and your wife decide to have a child, and the child goes and commits a crime, you are not guilty. You are absolutely not guilty. Now, how should it be different if it is a robot that you have created? More so if the robot actually evolves. Now, evolutionary computation actually makes these machines evolve, which means after this car has been driving for 6 months, if the engineer goes and looks at the internal mechanism that is driving it, it looks very different from when they actually release it. So do we have the legal framework to do that? Maybe not a perfect one, but it's something that we need to start thinking about. Who is responsible for killing that poor woman in Arizona? Was it the engineer who gave a go-ahead for the car to go to the road? Or if it is the car, well, you can't really arrest the car, yeah.
This should be the last question. So this is one of the subtexts I detected in the conversation about technological determinism on concrete social situations involving AI is a question of trust. On the one hand, because we know that AI will be enmeshed with daily life, human beings are forced to a certain degree to trust the decisions of artificial intelligence. The trust can be constructive; it can help us make better decisions, or it could very much be an unhealthy dependence on AI and on questioning dependence. And this is a question that was raised by many of us, because many of the people here in this room are concerned with questions about the human condition, but we're not technically competent to know how machine learning actually works in terms of the decision-making processes. And on the other hand, people who are familiar with machine learning and artificial intelligence may not have that broader, may not be introduced to those broader questions about human virtue, human frailty, and how human decisions actually work in society. So, the question is very simple. You know a lot about how computers make decisions, how machines will learn to make decisions. On the question of trust, what do you think is necessary from a governance point of view, from the technology makers and the people governing how technology works in society? What are the principles that they must follow, that they should follow, in order to build a healthy trust between society and technology? And the second question,
from the perspective of the end user, what must the end user, ordinary people, not university professors in humanities or in technology, what do ordinary people need to have that healthy relationship with technology in the new society?
Absolutely. I think the trust is based on the accuracy of data. Because these things are basically data-driven. So the outcome is dependent on the data that was used to train such a device. So if the data is not trustworthy because maybe the machine that is collecting that data is not accurate enough, then obviously such a machine should not be trusted, you know. But the problem is that human beings who are going to take those decisions do not know. You know, they do not know how trustworthy the data that was used to construct that machine is, you know. So the basis of trust must actually be the data itself. Obviously, you can do you can have regulatory framework, you know, open data. Data must be open, so that you know, when you train these things, at least they have been cross-validated by many people to increase trust, you know. Now, what should human beings do to trust technology? I don't think, or to interact better with technology. I don't think, you know, I think we have often relied on our colleagues to make decisions, you know. And I don't think it's going to be any different as to what were the elements that made us trust such decisions. Like, for example, if I'm making a big decision, you know, I normally will call my parents, you know, because I really trust them. I think they, you know, they are not always right. You know, they might not even have the full knowledge of the situation, but because of my experience growing up, I think their intentions are always good. You know, so do I have to, you know, take everything they say as gospel? Maybe not. You know, that's why we are independent people. Ultimately, if a machine is making a decision that has consequences, and we are the one who press that button, ultimately we should be, you know, we should take share a responsibility of the consequences.
Sometimes we don't even trust ourselves. It's been a wonderful discussion. Colleagues, please join me in thanking